We are going on with our series or playlist on complex numbers. And in this video, we are given a complex number of p equals to 2 minus 3i. And we want to prove that if we take p and divide it by its conjugate and write it as a plus bi, that a squared plus b squared would be equal to 1. So first, the conjugate of p would be equals to 2 plus 3i. So now I can take p divided by its conjugate, which would be 2 minus 3i divided by 2 plus 3i. And in complex numbers, we want to leave our denominators as real values. And we do that by multiplying both the numerator and denominator with the conjugate of the denominator. So we're going to multiply with 2 minus 3i, both in the numerator and denominator. And in previous videos, I showed you how to expand brackets with complex numbers. So when I expand, I have 4 minus 12i plus 9i squared in the numerator over 4 minus 9i squared in the denominator, where I squared is equals to negative 1. So that means we have 4 minus 9 minus 12i in the numerator, which is simply minus 5 minus 12i divided by 4 plus 9, because negative 9 times negative 1 would be plus 9. So that is equals to 13. And now we can rewrite this expression in the format of a plus bi. So when I split up the fraction, I have minus 5 over 13 minus 12i over 13. So the a value would be equals to negative 5 over 13, and the b value would be equal to negative 12 over 13. So a squared plus b squared would be negative 5 over 13 squared plus negative 12 over 13 squared, where negative 5 squared is 25 over 169 plus negative 12 squared, which is 144 over 169. And now I notice that the denominators are the same, so I can add numerators together, and that is equals to 169 over 169, which is 1. So now we have completed our proof. We have a complex number, and we divided it by its conjugate. From there, we rewrote the fraction in the format of a plus bi. We identified the a value and the b value, and added a squared plus b squared to prove that that is equal to 1.